Explanation of the MyEnergy Dataset paper. Overview and motivation. The paper presents MyEnergy, a comprehensive multimodal dataset designed specifically for large language model (LLM) applications in the energy sector. The authors, Kostas Mylonas and Magda Fati from UBIDEC in Athens, address a critical gap in energy research: the lack of integrated, AI-ready datasets that combine multiple data types. The energy sector is undergoing rapid transformation driven by sustainability targets and digitalization. While AI and LLMs show significant potential for energy applications including information retrieval, knowledge integration, and decision support, their effectiveness depends on access to domain-specific, multimodal data. Currently, publicly available energy datasets are fragmented, typically focusing on single modalities. Numerical data comes from ENSO-E or Eurostat, geospatial data from OpenStreetMap, textual information from policy documents, and satellite imagery from Copernicus, all existing in isolation. Dataset composition. The MyEnergy dataset integrates 4 distinct modalities: textual data 50,000 documents, includes Wikipedia articles on energy topics, news articles from GNews API, scientific literature from AR14, and official EU governmental documents from sources like the EU Directorate General for Energy and Acer. All text is stored in JSON-L format with consistent metadata. Imagery data 20,000 images, contains satellite images from Copernicus, aerial imagery from the INRIA dataset, energy efficiency labels from EPRL, building facade imagery from the IRF dataset, and contextual images from Wikimedia Commons and Wikipedia. Numerical data 25 million records, encompasses electricity load, generation, and market prices from ENSO-E, annual energy balances and macroeconomic indicators from Eurostat, building stock characteristics from the EU Building Stock Observatory, and historical weather observations from OpenMeteo. Geospatial data 2 million entries, includes infrastructure assets from OpenStreetMap, power plants, substations, renewable facilities, EV charging stations, the GridKit European Transmission Grid, the Global Power Plant Database, ENSO-E TSO networks, and Cordis EU Projects database. What makes this dataset unique? The authors emphasize that the contribution goes beyond simply aggregating existing sources. 3 key value additions distinguish MyEnergy: harmonization and enrichment. Heterogeneous sources are converted into a single schema with consistent attribute names, normal least units, and per record provenance metadata. This includes derived annotations like reverse geocoded ISO country codes and explicit relationship tables. Cross-modal linkage. Records across modalities are tied to common energy system entities through shared keys such as country, bidding zone, and geolocation. A property graph connects these entities explicitly, enabling retrieval of electricity series, satellite tiles, infrastructure assets, and documents referring to the same area simultaneously. Semantic enrichment layer. Harmonized records are embedded and indexed for semantic, lexical, image, and graph-based retrieval, making the dataset directly usable for retrieval augmented generation RAG without requiring additional processing. Methodology. The dataset generation followed a 3-stage workflow: data identification, selection of open-source energy-related data sources based on thematic alignment, spatial temporal completeness, technical accessibility, license compliance, and metadata quality. Data retrieval. Modular pipelines were developed for each modality using API access, web scraping, or direct download. Textual data used Python libraries for web scraping and PDF extraction. Imagery data used APIs from Copernicus, EPRL, and Wikimedia. Numerical data used APIs from ENSO-E, Eurostat, and OpenMeteo. Geospatial data used Overpass API and direct downloads. Data preparation, cleaning and harmonization applied to all modalities, including standardization of content, normalization of units, deduplication, and filtering of corrupted records. Each modality was unified under a standardized schema with aligned attribute names and data types. Technical validation. The authors conducted rigorous validation across all modalities: textual validation, language consistency 99% plus English, deduplication 0% exact duplicates, topical relevance 95% plus, and manual inspection of random samples. Imagery validation, file integrity 98 to 100% openable, format compliance 99% plus, resolution adequacy 95 to 100% meeting 256 x 256 minimum, and duplicate detection using perceptual hashing. Numerical validation, schema completeness, missingness checks, temporal consistency, and plausibility constraints, e.g. non-negativity for load generation. Geospatial validation, positional validity, schema integrity, and topological consistency verified through coordinate checks and graph linkage validation. Retrieval performance. The authors evaluated cross-modal retrieval using 50 energy questions annotated with relevant records. The hybrid retriever achieved, hit at 88% overall, ranging from 83 to 93% per modality. MRR at 0.73 overall. This demonstrates the dataset's effectiveness as an integrated multimodal resource rather than a collection of independent files. Usage and accessibility. The dataset is hosted on Zenodo under DOI 10.5281 Zenodo.16401633. It follows FAIR principles: findable, accessible, interoperable, reusable, and is released under a per-source licensing model. The compilation and metadata are under CC by 4.0, while constituent sources retain their original licenses: ODBL for OpenStreetMap, CC by SA for Wikipedia, etc. Complete retrieval and preparation pipelines are available on GitLab, along with database backends: OpenSearch for hybrid search, Milvus for dense vector retrieval, Neo4j for graph storage. This supports several use cases: continual pre-training of LLMs, retrieval augmented generation, text-to-image retrieval, knowledge graph analytics, and cross-modal analyses. Limitations and future work. A primary limitation is the dataset's European-centric focus, drawing heavily on EU institutional sources. Results may be less representative for non-European contexts. However, the pipelines are not region-specific, allowing users to broaden coverage by rerunning globally scoped pipelines for additional regions. The dataset is extensible, enabling users to integrate proprietary data or adjust retrieval parameters to expand scope, a crucial feature given the dynamic nature of the energy domain. Significance. The MyEnergy dataset represents a significant advancement for AI-driven energy research. By providing an integrated, multimodal, and retrieval-ready resource, it enables the development of specialized LLMs and RAG systems for the energy sector, similar to how domain-specific corpora like Galactica advanced scientific reasoning. This addresses the growing need for curated, structured knowledge bases to support energy transition through data-driven decision-making.